Hello, everybody. So tonight starts module 6. Is that right? Yeah, I'm used to everything in the 8-week classes. They all line up nicely. Through the math, through the 16-week classes still. But module 6, so our agenda has us looking at JavaFX, so the desktop style GUI package. And first thing to say there, that is what is written in the textbook is kind of out of date. It's that textbook was written a while ago. Talk about some stuff and then we'll get started with that. I guess first off, I put a couple notes on the homepage at Ivy Learn. I'm often looking for things to change about that, and the people here in the room said they didn't really look at that. So while I'm starting off talking, you might want to run an installer here. Because the stuff in the book didn't really even mention it, and I guess it was written, the chapters in the book were written very early. It has changed quite a bit since then. So to start off with, I wanted to look at the way we actually do it. So I put some stuff in the weekly to-do list. Hopefully we won't, I think we'll bypass that. And this also makes a good place to look at Maven. But we might need to download the jar files themselves. I thought I updated that. Yeah, the SDK. At one point I put on there to download the JMods, but then I remembered we looked at the SDK. We looked at the jar files, not the JMods, when we did MySQL, and I didn't want to change that more. We might bypass that and talk about Maven. It's a great place to discuss the differences there. But you might want this, go ahead and install this software right here, SceneBuilder. That's the drag and drop thing. So we'll just drag our mouse around and put buttons on the screen and stuff instead of typing it all by hand. And you'll see why. The way we would, so I wanted to start with the way we would actually use JavaFX to create GUIs and stuff. And it goes with the standard way to do that, which is similar to something we've talked about this semester, but we'll get there in a second. So where did the notes go? I pulled the notes out and then dug around looking for other notes and changed and everything got moved in a different order. So they're not at the front anymore. Oh, did they disappear on me altogether? I probably should have tried to be careful to put everything back in the same order. So that it would, okay, so sort of some reading off stuff here. I rolled the new smartboard in here to give that a try, but I wasn't really planning on writing much down anyway. Yeah, I was just gonna run off the background of it. So we've talked about the core idea of Java, right? The basic idea they started with was write once, run anywhere, which doesn't seem as extreme today as it was when they started creating Java. We used to have to write different code depending on what system we were going to run it on. But when they came up with that idea for Java, it spread quickly, and it's very, very unusual that we have to do that anymore. Unless you're doing like IoT devices with port manipulation style coding. And you're not really writing for a machine anymore, write one code, and then there's probably a collection of compilers to run it through or interpreters, depending on what system we're running it on. So that idea spread very quickly. And when they were first starting to develop Java, obviously graphical user interfaces were coming into play. It was right around the same time as Windows started to take off. They've been around for a while. Computers were getting bigger and bigger and bigger, and finally could handle the graphics and had colors and all that stuff on the screen to make them look nice. So it was coming along good. So they wanted to make a GUI package. And following suit with that write once, run anywhere theorem that Java is based on, they wanted that GUI package, a GUI package that would run well on any platform, as well as looks really good on any platform, user in and on, and some other stuff that we would expect from a GUI package. And they wanted to do it on anything, run on a Mac, run on a Windows system. Linux was very young. They probably weren't thinking about Linux at that time. It existed, but only a handful of people in Britain knew about it. And they were probably personally told about it by Linus Torvalds. Yeah, they're trying to do a project. So it was right around that same time, but there were other systems around then too, and I wanted to include those. Write it once, put together a GUI package that runs well, efficient, looks good on every system they run it on. They expected it was going to take them about 6 months. 9 or 10 months later, they released a panic version, and they failed miserably on every one of those attempts. So looked good on every system. It looks bad on every system. So I guess there wasn't a quality thing. It looked equally bad no matter what type of system you ran it on. Worked well. It crashed on every system. So they basically failed on every account they set out for. It turned out to be a much bigger challenge than what they were expecting. In a level that's hard to talk about in a class like this, because we always think about the high level programming languages. So this is back at the level where the compiler switches it to assembly language, and sometimes that level between assembly language and machine language. So the problems we're putting together things at that. So it's hard to picture with what we've been studying that they could spend that much time and how difficult it could be, but we're not really looking at the same level they were. There were bugs on every platform, and it looked mediocre everywhere. At best, it looked mediocre everywhere. The answer, there was a few good background things that were working cross-platform fairly efficiently, so they kind of cleaned those up and fixed up some of the general bugs, and created several more layers in the virtual machine to make a smaller, I guess, smaller universe for it to run in so that they could have more control over the bugs and clean things up. And the answer was Swing. It worked well. It didn't look terrible. A lot of y'all probably too young to remember, you were very young. There was this long stretch that you could look at a graphical user interface and tell that it was made by Java. It was very distinct because it didn't really match any of the systems. It had its own look, and it didn't quite match any of the others. So it was very obvious that it was a Java system. It looked okay, worked decent. It was kind of complicated for like developers. The best way to lay their controls was what's called a grid bag layout, and it was kind of hard to work with, even after lots of practice. It was non-intuitive to begin with, and never really, and you couldn't grow intuition on it. Notice the key word there was bag, not grid or template or anything we would think about using for a layout. They called it a bag, and it was like that. We threw stuff into a bag, and it felt like we were throwing stuff in a bag, and if we threw it in the right order, it would always end up in the same place. But it did kind of work, and this syntax had a lot of unnecessary redundancies, but it worked everywhere. We rewrote the same code, and it would run on any system we put it on, which When the first attempt, which was AWT, we will see those letters because some of the good parts of that are still around. The good parts were kept around and it worked everywhere. They abandoned their original idea. Or they had to set their original idea aside. And Swing was deprecated when they finally got the idea working. So they had the idea, that original stuff. The reason I was digging up these notes is because I thought I had a date in here. I'm pretty sure it was 1994. But I didn't write a date in my notes. I'd have to Google it. Early 90s. And finally, around 2014, they finally put together that system they wanted to make initially. It consistently looked well. It was easy to work with. The syntax, so like the Java naming conventions, things were consistent. We could, after we saw a few of them, we could start to predict what things would be called. So everything was spelled out with that nice naming convention syntax and stuff. And that finally replaced Swing. There's still some remnants around of it. And by the time that it did replace it, there was an issue that both Java and Python discovered on a very, very large scale, as well as Microsoft. And basically everybody that made a GUI package at that time, or everybody that made a programming language at that time. And that was a big issue with programming languages, is we need to keep backward compatibility. Because like all software, it's constantly updated. But let's think about it in a non-programming setting. Something like a spreadsheet or a Word document even. And you have some Word document that lists out the birthdays and addresses of everybody in your family so you can send them a birthday card every year. What would happen if when Microsoft decided to do the yearly update on Microsoft Word, that Word document no longer worked? Like no backward compatibility, so you couldn't even bring it in and reformat it. You just have to retype it if you needed to. It's that sort of situation only with programs. We don't want to lose backward compatibility. But Java, along with Python and the languages Microsoft put together, so Visual Basic, and then when they started to develop C# and they kind of got themselves stuck in it with C#, and that's when they realized it's like, oh no, we just got ourselves stuck with what we already did. And Python and Java were realizing at about the same time that if you include an official GUI package in your programming language, you're stuck with it forever. You can't get rid of it. Java's like that with Swing. So Swing still exists. You'll still see it. They can't drop support for it. You will get red lines in pretty much any IDE you try to type Swing in. You'll recognize them. They put J in front of everything, so like J button, J menu, J text. All of the stuff starts with a capital J and then has the name of the widget. So you might see it around from time to time, but they just can't get rid of it from the language. Python's the same way with the TK interface package. They can't get rid of it or they lose all backward compatibility. Microsoft is the same way for Visual Basic, and then they went ahead and included it in C#, so now they're stuck with it in C# with Windows Forms, even though they have an updated, better version of the WPF, which the W and the F still stand for Windows Forms. They put another word in the middle and the acronym instead of spelling it out, but they get stuck with that forever. So with JavaFX, Oracle had learned their lesson. So when they made it, it was around for a few years. They were so happy after working from the early 90s to the 20 teens and finally got it working. But they learned their lesson about keeping that part of the official language. So they handed it over to Apache, and technically it's been named OpenFX, and Then there's some weird things like, for some reason, the OpenFX, if you go Google for that, you'll find an unfinished Microsoft 3D modeling software that seems to have the domain name and was software that nobody's really working on, never got finished. So kind of looks like Microsoft just claimed the domain name or something and held on to it. But that's a different point. They added a J in there, so OpenJFX, but most people just say JavaFX still. And with Apache in charge of it, it's fully open source stuff. We can customize it as we need. They made some really good decisions. The Apache company that's a company, it's a subset of Oracle. So, and for the most part, it's a company of all programmers. You've heard their name before, probably on the license and from software at least. But as a company, everybody there's a programmer, except for the handful that got promoted to management positions. And they probably would still rather be programmers, just somebody had to take the middle management positions. So Apache usually makes really, really good decisions with the software they do. They are in charge of. So OpenFX, it's kind of like MySQL. We have to download the jar files and include them. But that is one of the things that is often built into Maven if it's the most common ones. So the MySQL one, we couldn't just do a Maven project and say we went in MySQL. We'd still have to do all those imports like we did the other day. But JavaFX is, there's really only one thing to import. It's not like which SQL database are we connecting to, which connector do we need. Maven couldn't figure that out, but there's really only one option. So the Maven packaging software can often handle that for us. But we're going to be talking about it for a few days. And I guess I'll go ahead and share my screen. And usually we look for optimizations. Java is for big things, so we still worry about those speeds. If any place we can buy back a millisecond. Because if we're doing an enterprise scale piece of software that we're expecting 50,000 users and 10 million customers to access, every time we can buy back a millisecond, those are going to add up to a significant amounts of time. So we still like to do that stuff. And one, object-oriented programming is good for the human, bad for the machine. So we lose a lot of time. And the standard way to buy back some of that time is to use a markup language. Things that are non-dynamic. And usually our GUIs are pretty non-dynamic. I could open anything on here. I'll open the Sublime text editor. The GUI itself is pretty non-dynamic, right? What's going to change is what shows in the output section. But that's really going to the background file. That's what it's handling. The thing that shows where files are, that's always over here on the left, unless I decide to hide it. The menu always comes up in this order. So a GUI itself is very non-dynamic, which means we don't need those major advantages that humans get from object-oriented programming because it's not changing. We don't need to worry about it changing. We just need to worry about where to put it. So it's pretty common to have our GUI itself, or at least some parts of it, handled with a markup language, kind of like we're doing with the JSP pages. We use a markup language for the non-dynamic layout, like where's this input box go and where's the output going to display, and then we don't have to do lots and lots of complicated code to figure those things out. We might come back and look at setting up the whole environment like we did with the thing. Let me just kind of start. Let's just jump in here. So we'll actually need a separate piece of software because a markup language is kind of difficult to work with, right? Everybody in this program had to do that for the SDEV 153 class. To drill that in your head. And that's what that software I just said to download and install was, that SceneBuilder. Because the reason you have to sit through a class where you do it all by hand is because if you're in this program, you're on the pathway to make the things where somebody's going to drag their mouse around and it writes all the HTML code for what the web page is going to look like. And you're on the path not to type up web pages with HTML. You're on the path to make a drag and drop interface so that somebody else can put together a website, and the interface types up all that HTML for you. Because writing a text file is easy, right? Everybody in this class is way beyond just open a file and write some text to it from a program. So there's a couple ones. I'll just start with a blank one. I click an empty one, kind of looks like this. So JavaFX, we start with containers. Everything needs to go into containers. So maybe a big anchor pane. That's the one that locks it in place. And then under controls, we have things like buttons and checkboxes. So the anchor pane is just that nice, easy. We just drag stuff over and it locks right in place. I'll just throw some random stuff over here. But note here, these are all independent. So usually we nest layers and layers and layers of containers. Let me go back to the container section. So typically we would do something, we'd have something like the anchor pane or a border pane for our big area. And then the ones we're going to use the most often are HBox and VBox. So that's horizontal and vertical. I stack those three up in a row, so I'm going to go down to VBox. So bring in a VBox, and then I can just throw these controls right in there. And that container is like the group section. So now if I need to move that, I can grab that container and move them all at once and organize things that way. Which should sound familiar to what you were doing in the SDEV 153 class with the HTML. A few settings here. There's some things over here. In particular, controller class. So it is specifically looking for something, a Java class that can connect to it. We'll see how to do that soon. Over on the right is a bunch of properties. So all of your different things. So containers and controls, the place to put pictures and labels and buttons. Might as well look at this. Some slightly fancier things. Fancier versions that they just had to go with the generic version for the official one, and then they do have fancy versions, fancier versions included. If you want to step it up, stuff about menus, random groupings and things like that. We'll talk about stage soon, shapes, bring in charts and graphs and all of that sort of, all those normal things we would kind of expect. Smaller, there we go. That way fits on there. Over on the right, we have a bunch of properties about it. So we have this GUI to put together our GUIs. Makes it a lot easier. And when I go save this, you'll notice the type is FXML. So FX for JavaFX, or technically the name changed to OpenFX in 2019, but most people just say JavaFX. And then markup language. And I think everybody in here has seen the markup language. Open with so normal markup language, so we have tags for each of all of those things we were dragging around. The anchor pane holds everything, and then it has a children tag where we layer up all those buttons. You can type that stuff if you would rather do that. That is how we most often do it, using something like SceneBuilder. SceneBuilder and NetBeans are made by Apache. Gluon is Apache is a subsidiary of Oracle, and Gluon is a subsidiary of Apache. It's a business model where they're not locked together as a single corporation, so that things can be shuffled around as needed. So they split up into lots and lots of different parts, and a big hierarchical structure of subsidiary companies that really make up the Oracle Corporation. And that way they can be split up and brought back together and shuffled around and mixed and matched as needed in a hurry, for whatever the current, whatever works best for a given situation. So we'll usually do that. We can also write do it in Java code. That's what the textbook has. The textbook was written before FXML was really developed, around 2016, 2017. So the textbook had to have been written pretty much as soon as JavaFX came out. So he probably had like preview versions of it. Daniel Ling has been one of the top names in programming textbooks for many, many years. He's approaching retirement, and he spent his entire working career writing programming textbooks. So he probably got an early view of it before the release and wrote the textbook up, and then it's just editing little typos is all they've done since then. So the textbook's a little out of date. It was written before JavaFX. We would normally do that and then only do the Java parts when we need to make something special. Like when we need to customize our button and not just like customize the color or appearance. We need a new type of button that doesn't already exist. We need to actually make a child class of button. And the only thing springing in my mind is already exists, but think about like a click on a button is what we would expect, but maybe we'd also want a long hold or a double click. Or those already exist, so maybe we could put them together. Sorry, I forgot to turn my phone down. And we could do a long hold, or we could do a double click, but we have a whole bunch of things we want. So we want a particular function on our button where we have to long hold and double click to get the button to do a certain thing. I don't know where that would fit in, but JavaFX is pretty thorough, so I have to make up a complicated event before we don't have to do it. When we need to completely customize that widget. So charts and graphs, we customize those. Those usually show up in there. Tables and charts and graphs and tables also use something called observables, which is the thing I've hinted at throughout this semester since the early days, because it's something really interesting, and the big payoff from that unwritten rule that we all write our Java code the same way. We can parse somebody else's code and adapt our code to their code, or adapt the code can become dynamic and adaptable because we all just kind of agree to write our code the same way, so we know how somebody else's code is written. And we can parse, it basically comes down to we're able to parse their code rather than just simply the output of their code like we normally have in programming languages. And the first place we'll kind of see that is with observables. So charts and tables, obviously those are all going to be unique. So those we almost always do in Java. We go back to the object-oriented class, make a class. But for the most part, our GUI we do with the markup language. So let's jump over to NetBeans to start looking at stuff, because we're going to talk about it in a couple days. I'm just mentioning some things, the standard learning, right? Preview, practice, review. So this is night one, so preview. So I'm gonna go in the ant one, like we've been doing all semester. Let's go over to ant and a JavaFX application, or Java FXML application. Okay, that sounds good. And next, I should get an error message here. Oh, it reset and I don't think I deleted the libraries. I might not get the error message. Oh, good. I still got it. So it's not configured. I don't have my Java environment configured. If you look at that error message, the first thing you'll see is to change my Java platform. Right now, there's only one Java platform. I believe I deleted the other one. Yes, so I deleted the other one. So it says, don't use the default platform. First step of configuring things to run with JavaFX. We're going to do this an easier way. I'm looking at the error messages here. So all this is going to be canceled out in a minute. Depending on where we're at next week, we might take a few minutes to set this up, but we are still restricted on time. So we might just go ahead and go with the easy way, because the easy way is using Maven, which is the modern way. And I'm pretty sure I've mentioned before, the only reason I'm not using Maven in the classroom is because in classroom examples, I might end up having to click into all those folders, and Maven's organized for a computer, which means lots and lots and lots and lots of folders. Things will be 20 folders deep just to hold one file. It's great for the computer, but it's a little inconvenient if you have to click into them to point at something in a classroom example. That's the main reason I've been going with AND. We normally use that. So we'd have to set up a different Java environment. And that's just like the first one. We can see here, have Java 18 installed. So I need to go in here and look for Java JDK 14 or earlier. It even predicted 14. So like it knew I was going to do wanting to install JavaFX. So I need to roll all the way back to 14. Which that wasn't in that error message. I just happened to know that one. And 14 is new. It was all the way back to 8. So it doesn't go sequentially either. It's not like 4 layers behind. It was on 8 until last June, and then it jumped up to 14. So it's back a couple layers, a couple levels, and the big reason is they want to make sure all the bugs in the actual Java language are worked out before they move that GUI in there, because it's harder to find in event-driven programming. When everything is completely event-driven, it's a lot harder to find all the little bugs. So they stay a couple versions of Java behind, so that the bugs are found before they put the GUI back. And again, that comes from the lessons learned over from like Swing. They learned a lot of wrong ways to do things. So now Java is very, very, very good about very, very good about their releases. So we need to go in here like we did the day one and just download JDK 14 or earlier. 12 has been around even longer. So they found even more bugs in Java 12 and fix those. But we need to go back to at least 14, download that, set up a thing, which we do. There's lots of buttons. It's a GUI, but there's one right here. We go to manage platform. Oh, I thought I deleted that. Let me remove that. Click add platform. We have a Java standard edition. Yeah, I'll skip we have the standard edition. Open JDK, that's the one that you open a Linux system, a Debian Linux system, and type sudo apt install Java. You get Java 14 right now. That's why I'm most clicked on that one. It's better configured. But to work with any number, we go into this folder, and we've seen it before. Usually, if we're pointing at a large thing like a programming language, we want to see the bin folder in the folder we select. So I can see bin right there. So that means this is probably this is the folder I want to look at. Select all that. Why is it not going in there? Do I have to go in bin? Standard edition. Go to next. It should be this JDK folder. Okay, now there's the next button. Go in next, give it a name. Then we hit finish. Now we have 2 versions of Java installed. You may do that in any other Python classes. Did you ever set up more than 1 version of Python? We can set multiple versions. So Python's an example most of you all have seen. My favorite machine learning library to work with is PyTorch. Probably just because I've done more stuff in it and I'm more comfortable with it. But Facebook or Meta they haven't done their latest release on that in several years. The changes they made were big changes that the average person and average computer aren't going to handle. So the releases go all the way back to Python 3.79. We're on Python 3.11 now. What is it? 3 weeks ago, Python 3.11 came out. So for doing that stuff, I often like to keep my favorite version, or the version of Python that works with my favorite machine learning library around. Also want to keep the newest one around. Have different projects that are at different stages along the way, written with different versions. So need to have several versions or test environments. That's where it shows up in the 220 class now. When we do Django, we create a virtual environment so that we have a completely blank slate, so that when we migrate that to a web server somewhere, we can recreate the whole thing. We won't accidentally miss something about how our version of Python was already pre-configured before we even started the project. But we can have multiple versions of a language installed. So now I have 14 and 18 together. They have different libraries. So if I'm on Java 14 and scroll, I'll see classes. It's not categorized in libraries, but I was trying to see if there was different libraries brought in here, but they're not categorized very well. But Java 18 is going to have different configurations and adjustments that have happened along the way than that new one. So we do have to set that up to work with JavaFX. And then we have to actually download those, which that's really easy. Just go to Google and download them. Download JavaFX. And it should correct it to OpenFX. Oh, actually, they just OpenJFX is the actual name now, but everybody still calls it JavaFX. So I guess the only place that actually shows up, the official name actually shows up. I guess it's kind of like ECMAScript. If you said ECMAScript, very few people in the world would realize what you're talking about, even though 99% of programmers know ECMAScript, and they just that's the official name of JavaScript. That's what goes with the HTML5 standard. So we'll come over here and find the download button. There it is. For all kinds of fancy animations and stuff. Slow down and just look for the latest long-term support version. Looks like this one that came out in September of last year is supported until they've got support planned until 2026. And the one that came out 3 months ago, it doesn't have long-term support, so they're still looking for bugs. If you want to be a beta tester and help them find the bugs, that's probably good, but probably not good for the learning it for the first time. You don't want to look for bugs at the same time you're trying to learn it, because then you don't know if you're doing it wrong or if it's a bug in the program. One of the bugs you're trying to help the developers find. So we go back to the latest long-term support version. 17.0.4 version 19. That does not have long-term support. We need to go back to probably better on the filters. So the filters actually have the LTS version. Look for the LTS and download the one for your system. No surprises there, right? And there's different ones. Notice we have either SDK or JMods. So SDK downloads the jar files. So that's like what we looked at in MySQL. The JMods download the files that have the extension .jmod. And it behaves the same way. It just, you can configure your system to use one or the other. Really, setting up your libraries and stuff, it's no different. It's just, you choose. When setting up your IDE, you just choose the option to use JMods instead of jar files. Let's see, I'm on Windows, so I'm going to, where's the download button? Oh, is that it? Oh. Are none of these buttons? They look like buttons, but they seem to just be text. Oh, there's download buttons. Oh, that's 19. We're showing version 19 again. Okay, well, I was going to do it a different way, so I guess I'll download version 19 because there's a download button for it. Download the SDK files. And then it's just like we did with the MySQL stuff last week. We go to downloads and extract that. Well, actually, we had to go a roundabout way because they made an installer for the MySQL, and I'm not sure where they did that. But if we go in here, we eventually find the not in the bin. Legal one has a bunch of stuff here. That just looks like documentation. Probably could have guessed that from the folder. Looking library. Okay, here's a bunch of jar files. So that's what, like we did in MySQL, when we find that jar file, the actual final build of the project. And here's the base ones, basic ones. 3, 4, 5, 6, 7, 8. So it looks like in Java 19, the one that just came out a couple months ago, they've adjusted stuff so that we have these 8 basic ones. So pretty much everything we need should be in 6 of those 8. Java Swing and SWT you will almost never use. But this one and 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 this one you would use a lot. So you could leave those off, but we're just going to copy and paste and bring them in. So you might as well bring in those other 2. They keep cutting down the other one, so I think they're consolidating it. It looks like the latest version, we're down to just 8 of them. But for a long time, we've only used 6 of however many they give us. We just really need those 6, but download those files. And then it's like we saw before, we need to create the library so we can use it. We go through here and set up that environment and tools, create a library. I need to delete one. I don't see a JavaFX on here, so I'll create a new library called JavaFX and just add those folders to it. Downloads, probably copy them over to someplace better. I'm getting ready to delete this, so select all of them and add that in there. And notice there's also I'll come back over here and point at it. Notice we also have source code. It is an open source project. So if you want to, you can just go in there and modify it any way you want. So you don't have to even make a subclass. You can, it's open source, so that means you can get back to the parent object that you're trying to extend, not just extend it and make a child. And then the stuff we did earlier, like right click, after we create a project, go to properties and include that. In the module path, include the library in the module path. And apparently forgot to say this the other day, there was a question about it. On the web app ones, when we go to libraries, it looks a little bit different. So you have to say to refer to it, but this only tells NetBeans to refer to it. Is that what was going on, Nolan, right? So you had all that. You'll notice in web pages, there is these two files, meta, INF is short for information. So metadata and web data. Usually you want to copy that the driver. So last week's project, I think that's actually a homework assignment. Several of y'all are going to need that in your final project. So you take that driver that you stored somewhere locally, but when you upload to a server, it's not available on that server. So copy and paste that into the web INF. There's also a way to have NetBeans do that for you, but really what it is I think that's what you were saying was going on. I wasn't sure the other day. I looked at the error message and I had to reinstall XAMPP. So I did that and duplicated his error. But he said he's fixed it. He fixed it by the time I duplicated the error to try to figure out what it was. But I'm thinking that's what it was. That's what went wrong. Have to make sure that that library you need, which isn't part of the actual language, is right there on the website that you're building. There's a menu option to put that in there as well. If you want to know where the menu button is, you can ask, contact Nolan in the chat or something, and he can tell you where the menu button is. But I'm pretty sure what it does is just copy and paste the thing in there. But that's a little side step. For JavaFX, similar thing. We right click. We're doing it all locally, so we don't have to worry about sending those files to the web. To a certain extent. Let me pull up one of our projects and jump over to GitHub. If I go to buttons. Oh, there's the web app. I'm redoing the project I'm looking for as a thing, so isn't that going back? Going this way. This is the last big thing I did with JavaFX. But I'm redoing it as a web application. It's basically for my own bookkeeping purposes. I didn't want to use a basic spreadsheet. I wanted to do something that would automate the standard double entry style accounting. That was one of the things I studied when I came back to school. I was looking for redundancies. So one of those backup plans was tax accounting. So I figured no matter what, that's a way back on the feet within a year's time. Within a year's time, I know there's going to be people need to hire tax accountants. So it seemed like a good backup plan. And it's a good system. So I didn't want to use a spreadsheet, but accounting software has grown massive. Anybody's used things like QuickBooks. Like QuickBooks isn't even a college course anymore. QuickBooks is 2 or 3 college courses because it is just so bloated. It just keeps growing and growing and growing and growing, and nobody's stopping it. It's way too big to get anything done. Get lost in software that big. Most accounting software has become like that, or it's stripped down to just be a spreadsheet. So really, what I wanted my own automated. I know there's pictures. Okay, I wanted it to look like the traditional checkbook because I learned to do that, balancing a checkbook with the ledger in the back of an actual paper checkbook. Those things still exist, but we never write checks anymore. But I wanted that appearance, all that information, the standard way to do it, and then automate the debit and credit columns and balance everything. So I made my own software for it. I use JavaFX on it. So if I go in here and in the installers, so like the source file, if I look in here, there's FXML files and Java files. So the non-dynamic GUI stuff is in FXML, dynamic GUI stuff is in Java, and then Java files to tie them together. It's kind of what we're getting ready to look at. So instead of looking at just a simple one, the book has that. It's easy to find examples for it. I wanted to talk about that tie together part because that's the one that's harder, that's less intuitive. Right? We can find plenty of examples of FXML, we already saw it. That's a drag and drop interface, and it runs all that for us. We can find plenty of examples of Java code that could be, but the tying them together is a little bit trickier. So I wanted to make sure and talk about, that's the part I want to talk about first, because that's what you'll actually do with it. Otherwise, it's like everything else, right? How do I click the button in JavaFX? That's how we usually write our code, right? But then the thinking part is once we write the button in JavaFX, or really we'd write the button in FXML and we'd write the fancy Java class that button needs to activate, bringing those two languages together is the trickier part. So I want to make sure and focus on that sort of integration. But this one was done that way. I put together the particular version of Java that I wanted to use. I think I used 12 and 8, the two versions, not the two that I downloaded this evening. Which means when I go to install that, I need to have those versions there. So I guess it's kind of like copying that MySQL thing over to the thing that's actually going to the website on your homework assignment or what you're doing in your final project. We need to make sure those are included. So we're in create installer files. Oh, it's not there. Well, I can look at the launcher. Which one should we look at? Windows, Linux, or Mac? Any preference? Okay, let's look at the Windows installer. We need to check this. So this is that thing that I talked about briefly before our break, remember? You don't want to just trust your human user to start the file. So we want to check and make sure that JavaFX exists. And if it doesn't, we're going to print out that little black box that hopefully only pops up for a millisecond so the user doesn't see it. But sometimes it's there for a second or two. You all have seen those many, many times. Console pops up and then disappears, and then the actual software opens. We'll put some words there. Okay, we need to download some stuff. So I'm going to go here and, oh, it looks like I was using 11.02. I'm going to go over here, download the JavaFX, open JFX package, zip it, and rename it because that looks like it's hard to work with. Then I'm going to start PowerShell because when I typed this up, I remembered the PowerShell command to unzip a folder, but not the Windows one. I thought it was unzip, but apparently wasn't unzip. And I couldn't remember the other one, but I remembered how to do it in PowerShell, so I just opened up PowerShell and did it there. We can do that sort of thing in batch files. And pretty much any Windows system has both PowerShell and command prompts. As long as we pay attention to which one's which. So yeah, download it and unzip that folder. Opening it up. Oh, and here's what those like right click and put it in the properties and stuff look like. So set up our class path where things are going to get compiled to. Our module path. In our module path, we add modules, and here's several of those jar files that, here's several of those jar files that were downloaded in that file that was just unzipped. So confirming that all the resources are in order. You want to think about that stuff. What else did I do here? Add opens, add exports, yeah. So just set everything up, reset up that environment. And that's assuming that somebody has Java. And Java is just installing the particular Java runtime environment is very, very standard. So I stuck that right in the exe installer. So the exe installer goes in and runs Java because that's so common. We don't have to ask if somebody wants to install Java or not. If we need Java on their system, we just install it. Same thing with Python. If we need Python on their system or Java or C#, well, C# only works on Windows ones, but Java or Python, if we need it on their system when we install software, we go ahead and install that. We don't even have to ask for permission because it's really surprising if they don't already have Java or Python on their system. Some of the more obscure ones, there might be a message or a warning pop up. Like it's a lot more common that somebody's not going to have Rust already installed in their system. So we might give a little bit of a message about Java or Python. If for some reason we don't see it, we usually don't even ask permission for that anymore. Not in 15 years or so. That might just have to do with the most popular programming language thing. Because when Python became the most popular programming language, it took the crown away from Java after holding that for decades. Maybe it's because of that. But that sort of idea in the batch file and the other two do the same thing. It's just for a Linux machine. If JavaFX is not there, download it, unzip it, throw it in there, or on a Mac, which a shell, same thing. I just wrote the Z. I just wrote it for Zesh instead of Bash to keep it straight for myself. I think I got confused once, put the wrong one in the wrong place, and there is a slight difference between the scripts, but not anything significant. But we need to install that, and on some other ones, I would just go ahead and include it here. So it's just amongst the files that get downloaded. So eventually there's just the exe and pkg installers. I usually like to make a dev file, even though Linux users do not want an installer, they want the tar files. I usually just go ahead and make a dev file as a sign to Linux users that it was tested on Linux. It's like, okay, here's a Linux installer, and the tar files are also available, but this is at least clearly indicates that the stuff was tested on a Linux system. But we have to do things like that if it's not already on the system. We have to install it. Hopefully we can set all that up. But that's one of the advantages of Maven. One of the big changes is that central repository, the single place. There's one manifest. There's one repository that holds all of Java stuff, all the different versions, and it's managed by really, really good programmers, even by working in Apache standards. So they keep up on it. If we ask for a JavaFX project in Maven, so go to Maven and scroll through the option, and here's a JavaFX FXML Maven archetype put together by Gluon. So the repository was prepared, the repository where the template's going to be pulled from was prepared by the people who are actually in charge of that language. Definitely the people you want to pull them together. So Maven's the more popular one. And hopefully this, yeah, you'll notice there's no warning messages. It doesn't tell me that. It just, moves forward and tells me which version of the language it's going to use. It doesn't give me some words in red telling me what version of the language I need to go configure and set up. It's a central repository, so hit finish. So it connected to everything. So I guess we'll use this to talk about Maven projects. We've seen Ant, that organization, where the source code goes, where the class files go, where the final distribution goes, where the Java doc goes, how we organize it. Our manifest is here. That's an important one right from the get-go. Under project files is POM. So here's pretty much the whole manifest. An XML file. And you would need, if you like to do things manually, you would need to add that to your dependency list right there. A new dependency and the group ID on it is org.openjfx. So their URL switched around backwards. It's not really reversed because the words still go in the right order. But their URL is openjfx.org. So switch those around for the company folder names. And the reason they do that is so you don't accidentally type in that URL when you want the folders. That way the web address is different than the folder structure. They switch around, but the names are the same, so we can follow that meaning in the names. What it's for is this JavaFX controls, which version it is. So we need to include that, which it included twice for some reason. Looks like a patch. Include plugin 0.04. So patch on something, and we would need to include those in our manifest. So centralized location. Every piece of information about building this project is put in one file. Everything's centralized. Everything Maven knows about. Maven can only go one place to look for stuff. It can only go to the Maven repository. Even though here in NetBeans, I can come over to source. It's under team. And come over to team and go to Git or Mercurial or Subversion, and I can go to different repositories. Let's just clone. There's our class repository right there. I'm just going to pull it down. So that folder exists. There's probably a folder by that name because I always use that same name. Yeah, that was existing from the previous class. Make a new folder. More Git stuff. Not feeling very creative on that name. Go browse here. Okay. Next. Hold on the main branch. Parent directory. Go ahead and scan it for NetBeans project. So even though I can connect to any repository, the three primary protocols used on repositories are there. Maven has a very specific place. It'll only go look for Java stuff in one place. 17 projects were cloned. Do you want to open one of them? Sure. Let's go ahead and open what's not here. Pizza's here. Java application 12. That's something we did earlier in the semester. I have no idea what number we're up to. We got to be in the 20s or 30s. Got to keep deleting. I keep deleting them too. So this is tied right into GitHub. Usually we get a little symbol there. Maybe they changed it. Because I didn't actually sign in. I just pulled them. I didn't actually sign in, so I can't push them back. Download them. But normally a little G shows up at the bottom of the coffee cup to say that's synced to GitHub. So we can do live syncing. We can basically redo lifetime packing in NetBeans right there, just like you get in any IDE, that's nothing special. I was just going to point that I guess the main thing there is that don't delete the source code. The main thing there is that that's where the button is. Because I don't think we pointed to that in class. That's nothing special. Pretty much any IDE can. We wouldn't call it an IDE if it couldn't connect to GitHub. I guess knowing all three of the main protocols by default that was really nice. Not all of our IDEs are going to have all three protocols by default. But yeah, that's nothing special. Being able to do that right in the IDE is nothing special, so that's where the button is. We hadn't talked about that in class. But Maven has their own repository where they keep all the Java stuff, all of the stuff that's related there. Yeah, we've talked about it before. Everybody in here has had Python. So it's like I can't say the word right. It's but I always say PyPeople. PYPL. We're supposed to pronounce it like people, and it starts with pi, but it just won't fly out of my mouth correctly. People, y'all have seen the site, I'm sure. Anytime we want to do something with pip, we just Google pip. We get right to the PyPeople. Piple. I can't say it right. I just say PyPeople, and most people seem to know what I'm talking about, but it just doesn't flow off my tongue. This site, the official location for all the stuff that's not actually part of that. That's modeled after Maven. So that idea only for Java. That's what you're getting with Maven. Let's see. Let's open up some files. So we go in source packages. When we're in an IDE, it will skip all those folders because those are just for the computer's benefit and very, very counter to a human benefit. But there's a long string of folders here. So there's a com folder, then a my company folder, then a Maven project 3 folders. I guess only 3. That's not too bad. Then we have app.java, primary controller, and secondary controller. And our Java code looks like this. Basically, we have an annotation. So at FXML, so that annotation is saying, look at an FXML file. In particular, look for an XML file called primary.xml. It's on the extension is arbitrary, so that's usually just left off. I always type it in myself because there might be other markup languages there and words might carry over. But over in our default packages, oh, not there. Under other sources, there's a other sources folder that has a folder called source, a folder called main, and resources. And in there is another folder called com, and a folder called my company, and a folder called my Maven project 3. And in that is a couple of FXML files. So we're pointing at all. Oh, I didn't mean to click on that yet, but did y'all notice what it opened with? It didn't open with NetBeans. If you want to open it with NetBeans, use the edit button, and that gets you the text file. But you see look at all those folders. That's why I wanted to use, that's why I've been using Ant for most of our classes. So we have this FXML file called primary. So then we have a controller that opens that up. And then we have the actual app. And our main loop, I really like JavaFX for what the main loop looks like. That's what a Java main loop should look like. Our textbook never writes a main loop, a main method that looks like that. I shouldn't say main loop. That's what a Java main method should look like. It should have one method call and that's it. And that method call should probably go to something that is in the parent class of the one we're making. So JavaFX does have like the best example of what a Java main method should look like. And then all the code is in the objects. It launches it and then there's this is the main one. So this is the one we have to do every time. Notice the override annotation. If I cut this out of here, we get that error message. So we've seen before that app is abstract and it does not implement the start method. Or it probably doesn't say that explicitly, but that's what it means. It doesn't, that's the one we have to do. And what we do is we create a scene. There's a lot of theater or movie name referencing. So we create a scene. So our GUI, every window in that GUI is a scene. And then we put the scenes on a stage, right? So like a play. The audience sits in front of one stage, but we can show lots of scenes on that one stage. Sometimes moving scenes, right? Scenes dynamically change during the play, so that we don't the audience doesn't have to wait or something. But we load everything in the scene, then we put that on the stage, and then our actual call to it is stage.show. And then when we call launch, a bunch of background stuff happens, and then it calls the start method. So appropriately name starts. So that analogy is a good way to think about how you're putting your stuff together. Your buttons and and other controls are like your actors, and your containers, the H box and D box, those are the ones we're going to use most often when you look in the text box. When you look in the textbook, you will see those all over the place. Horizontal box, line them up in a row, or vertical box. And we can put vertical boxes inside of horizontal boxes, and then have a bunch of vertical things lined up in a row to make a table. That's your layout. So like your script, what those actors follow, and then we throw that script and all the actors up there on the stage for a particular scene, and that scene's on the stage, and then we are showing the stage. So the metaphor works really, really nicely. It kind of flows out intuitively. Guess I should hit run button. Oh, and you probably noticed, I'll go ahead and close the scene builder to do that again. This is the point where I meant to double click on it. Instead of that, if we double click on it, it's set to open with the scene builder. We do have to set that in NetBeans. Go ahead and hit run before a break. Okay, that was weird. I don't know why my screen went black. That has happened twice when people have been by my office hours. Their screen suddenly goes black, and since the latest Zoom update, so I think that might have been a Zoom issue right there. I've seen it happen to other people. I've been on the other end of it. Is my video? Can you all see my mouse moving on the video? Okay, I see head nods here.
Yeah, we see it here.
Okay, from being on the other end of it, I know that the audio was still going through whenever that happened. But I think I've seen it twice in office hours. I think that might be a bug in the latest update of Zoom. So we got two buttons on here. We can switch views. We're looking at the primary view, switch to secondary view, and there's a different label there. Nothing fancy there, but that gives us a good starting point to start clicking around and messing with things, changing around, seeing what's there. Tools, options, JavaFX, you'll need to say where SceneBuilder is. Otherwise, did anybody else click that new Maven project and create an FXML one? Did it just go right through? No warning messages or anything? All right, we should be good to go. I saw head nods from at least one person that I know has basically the default configuration. I think the other person in here is doing it. So you might want to set up so that you point right to SceneBuilder. I'm going to leave that on the screen here as we take a break, so that if you did the default installation, you can see where the default installation of the SceneBuilder app is, and point to the folder not the application. Normally, we would go point to the application, so that's probably where your intuition is. But this folder has, you'll see bin and live and a whole bunch of stuff, and the application is in that folder. Make sure you point at the folder, not the application there. Otherwise, Tim, doesn't sound good. And then we'll start making little changes in there and get used to this. And then we'll get back to, then we'll do this later this week. We'll look at the stuff that the textbook covers where we do it all in Java. But this is what you would actually use, the FXML. That's the modern, current world working version of how we do that. But let's take a quick break. I'm getting very thirsty. I'll see y'all in just a moment.